Hi again. Hi, everyone. Paweł Fiderek here. I promise our organizers to run this session in English, so I will do my best to do this because I consider myself as a man of my words. So today we'll talk a little bit about edge computing. And maybe you already met me at some conferences and you know that I really like to connect stuff. I really like to show something that actually you can touch. Recently, even on the Azure Day, I show how to connect Azure Sphere, how to do the analytics against the data coming from the Azure Sphere. But I thought I have this feeling that this session can be a little bit different, because one thing is that we cannot see each other face to face. There is a distance. So pretty much, even if I show something to you, you don't really have to believe me that I connected. Okay, you might think that they're faking. So I want to run this presentation, this whole speech, in a little bit different way. I want to tell you about the edge computing, and my ultimate goal is to show the potential which is there, which is in the cloud computing, and why we are observing this huge hype on the cloud computing, on the edge computing. And I will tell you about this hype because I see it on the daily basis at my work. Okay. Uh, of course, as all of my presentations, there not be only theory. I will give you real life examples. I did some research. I read some research. Of course, I will share the information I found. And at the end of the presentation, I will give you the edge computing example from the real life. And it was quite exciting, and yeah, I simply cannot wait and looking forward to tell you about it. But actually, how this presentation will look like, how it will be organized. So at the very beginning, I will tell a few words about myself. I really don't like to do it, but I think that it is quite important because I really think that if you get know me a little bit better, if you see what I'm doing, uh, it will make my work a little bit more legit. Okay, so you will understand that. Okay, I'm not the guy who read a lot of the internet, subscribe for the few YouTube channels, and that's it. But everything that I'm talking about on my presentations, I actually do on the daily basis. This is like my real life job. Yeah, this is what I do. So start, as the title said, we say something about the connect, how to connect stuff. Of course, we'll focus on this edge. So what we are connecting, where we are connecting, and how we can connect stuff, okay? Then process. Of course, what we want to process and what actually we are processing, why we even bother, and how we can process. Of course, there are two dimensions of this how, because the first thing is how from the technical perspective, okay? The technical perspective, the technology perspective. What options do we have to do the data processing, okay? Because at the end of the day, there are some data, okay? And how much in gold, how much does it cost, okay? Because if someone allows us to use his infrastructure, his know-how, and when we are on the cloud computing path, so we are talking about the clouds, okay? And when we are talking about the clouds, actually we have three deployment model of the cloud, okay? So we have the private clouds, we have public clouds, and we have hybrid cloud. Since I'm really into Azure, I will tell you about the Azure, and the Azure is the public provider, so I will talk about the public cloud. And trust me, whatever we do in the public cloud, it costs something, even a little penny, but it costs. But I will show you that, okay, there are some free options of data processing, even quite advanced. But if we are talking about the production use of it or usage of it, using the free tiers of the services is not always the best option. Yeah, but we will go to that. And then, of course, the best part, earn money. And this is the part where I will tell you about this research I've done. I will tell you how actually the money can be if we are talking about the edge computing. And I will give you the real life example, okay, how our partner that we used to work with save some money, okay? And by some money, I mean a lot of money. And by saving money, of course, we can understand also earning money, okay? Because these are the money that you are not losing, okay? But let's get to the point. So really, a few words about myself. As I was saying, my name is Paweł Fiderek. Currently, I'm working as a Chief Cloud IoT Architect in Transition Technologies PSC company. I'm also the IoT evangelist. On my previous job, I was working for ABB for about 5 years, where I was also the technology evangelist. I was responsible for the system integration architecture and data modeling. So my, let's say, work path is pretty much consistent. Okay, but not only work, because we are working only for the part of our lives, but our true life is after work. So after work, I do my best to share the knowledge I gained. So we can meet each other on a lot of conferences. We can catch up on some meetups, some workshops. I used to do a lot with the Azure users group, especially in Łódź division, let's say. Now I'm moved to Kraków. I live in Kraków for almost a year right now, so you can most probably find me here. But since we have these remote possibilities, a lot of remote possibilities, you can pretty much find me everywhere. There even was a time that I was afraid that I would start to, jump out of the fridge, but doesn't really happen. So we are quite okay. Yeah, I'm not only the pure technology guy. I love to travel. I love to sport. Yeah, and to make myself legit about the data processing, I finished PhD studies in fuzzy logic at the Technical University of Łódź. So yeah, I have few things to say about the data processing because I was specialized in fuzzy logic. Yeah, so hopefully you will find something interesting in my speech. And now I invite you for my future presentations. Yeah. Okay. So let us start. Okay. So actually connect. What we can connect and what actually we are connecting. Okay. Let's imagine this logical split. Okay. Between stuff that is dedicated to be connected. Okay. So the stuff which was created to be connected to some systems. By the system, I currently understand the cloud. Yeah, this is kind of the shortcut. Let's understand this connection that we are connecting the device to the cloud. Of course, we can connect the stuff dedicated to be connected directly on indirect. Okay, directly because it has some computing power. It can implement some software. We can run some piece of software on top of it, and it will connect. Okay, it has the internet connection, and so on and so on. By indirect, I understand that we can have some kind of the gateway, some kind of the edge device, very close to this device, or very close to this device, which will push the data from this device to the dedicated system or to the cloud on behalf of that device. Okay, so what we can have here, of course, all this smart stuff, okay, smart bands, smartphones, robots, industrial production line, embedded stuff. Yes, something that you can imagine, something what was developed to be created, to work in a little bit bigger ecosystem than its own. Of course, these are the independent devices, yeah, but the true value we can get from it is when they are connected, okay? So this is the stuff dedicated to be connected, but we also have things, okay? We can connect some heater, fridge, or even a cow, okay? You can ask me how to connect cow. Nothing easier, nothing easier. You can, in example, check what is the current temperature of the cow and send this information to the cloud. Of course, you can also check how much milk we can have for this particular cow, this black and white cow, yeah, number 1, 2, 3, whatever mark on the ear it has, okay? So we can, let's say, retrieve some data, but it's not so straightforward way, yeah, and still push this data to the cloud. And this cow basically is not so bad example, because we can separate domain of the IoT, let's say, IoT, how to say it, paradigm, IoT paradigm, and this is agriculture. Okay, so the huge domain, agriculture, is focused on connecting stuff associated with the agriculture. Of course, we can have the facilities and the bar house and so on. There's some even devices, okay, or vehicles we can have on the farms and so on, but we also connect the data associated with the animals, okay? Of course, to make things clear, the cow has not plug and play stuff that we can simply connect it, okay? So we need to have this gateway. Okay, and of course, we can have something which is called hybrid, okay? So in example, TV maybe is not the best idea, but let us try, okay? TV as a device was not really developed to be connected to the cloud or to the internet, okay, at some point back, okay? Now it is created with the optional connection. It's still fully functional device without no connection. It can, you know, show your favorite programs. You can connect some, I don't know, pen drive. You can use the games if you have some smart TV and play with your TV pilot. There is no problem with that, okay? But it can be connected, but it really doesn't have to. It's still full functional. Doesn't have to. Sorry, it's still full functional. But if you connect it, you can extend its functionality of the functional and add the functionality of the system that you just connected to it. Okay, so in example, the cloud or the marketplace. Okay, so you have now access to the various applications from the marketplace, and you can use it. Okay, on your personal TV. Okay, so let's have it. Keep this on your mind. Okay, so we can stuff that is dedicated to be connected. We can stuff which is not really dedicated to be connected, but we're still connecting it. And we have the stuff which can be connected, but really doesn't have to. Okay. So how to connect? Okay, and because I promised that I will talk about the edge computing, let's focus on this indirect connectivity. Why we even using the edge gateways? Why we even the edge devices? Okay, so we are using the edges basically, so 30 devices as a kind of the interface between the cloud, yeah, in this scenario, the cloud and our devices. Why? To cover 4 basic scenarios. The first one is to translate. And the cow I mentioned before is a really good example here, because we are translating protocols which are not cloud native in this scenario. So of course we can have, I don't know, OPC, we can have Modbus and so on, and we can have the cow language, okay, and or the cow statistic, which are not really cloud basic, but we still want to have some data or use the data for the calculations or just store it in the cloud, just in case if we will need them. Okay, so the first scenario, the first use case for the edge devices is to translate legacy protocols. The second is to compute. Okay, of course, we can say, but come on, we have cloud, and the cloud allows you to compute pretty much whatever you want. It gives you the infinity possibilities, give you the computing power, the memory, the storage, just name it. Okay, you can have everything in the cloud. Yes, but before you have all these opportunities, you have to put this data in the cloud actually. Okay, and imagine scenario that you have the farm in the middle of nowhere. okay, if you have one 3G SIM card, okay, and 100 cows, okay, it's still okay to have 100 cows there in the middle of nothing, because there is a really good, really good food for a cow, okay? Just out of the fence, just put the cows there and they will start to eat the grass, and everyone will be happy, okay? But still, you don't really have the possibility to move the data in the real time, because the data are huge. The volume of the data is huge, but your connectivity medium is slow. You simply cannot push all the data. So you are pretty much forced to do part of the computation on-prem, okay? You cannot do simply everything because in the cloud, because the data are unavailable. All data are not available in the cloud because you couldn't push them, okay? So you do some of the calculations. In example, the very good scenario and the very good example, in my opinion, is that you are calculating the aggregates, like averages, standard deviations, and so on for your data. And you can even say that these are the kind of the KPIs for you, okay? But let's stick with the aggregates and just push the aggregates to the cloud. In example, I don't know, 5 minutes, 5 minutes averages or something, something like that. So it will reduce the volume of the data significantly, but you still can do some high-level analytics on top of this aggregate, okay? And if you run the analytics on the cloud and on top of the aggregates, and if you found something interesting, you can always call back for the raw data and say, okay, I found something interesting, some anomalies in this period of time. Give me the raw data for this period of time. I will do the deeper analytics. Okay, I will do the deeper analytics. So this is one of the scenarios. Of course, you can imagine a few more. Another one is the hardware utilization. You can say that it's funny, but it's a very popular scenario, okay? Because on the market, there are not so many cloud native companies, okay? We can see the transition right now from on-premise to the hybrid and maybe some directly to the cloud, okay? So when I talk with the people, with the managers, I often hear, but Paweł, we invest, I don't know, $millions of dollars in our hardware, in our local ecosystem. So now you say that pretty much we can do whatever we did here locally on the cloud and simply pay for that stuff in the cloud and still have this hardware here. I don't know, we maybe do not have to do the maintenance because we will stop using it, but come on, we have these capabilities. Maybe not 100%, because if you want to do the same level of the calculation as we can do in the cloud, we still have to invest on our hardware. We still have to buy computing power, buy units, orchestrate them, update them, check the security, and so on and so on and so on, okay? So here is the perfect scenario to going hybrid, okay? So we can utilize the hardware which we already have, and simply split the calculation. So let's on-premise, close to the device, let's focus on the device critical stuff, and let's do the device critical calculations, okay? Like in example, if my device starting to overheat or something like that, let's keep this checking for overheating of our device on premise, okay? Since we already have this hardware, we can simply reuse it, and this will reduce the cost of the calculation in the cloud, okay? So we won't have to do it again, and keep the cloud for some real hot stuff, okay? So from predictive and so on, yeah, for processing the context, and I will tell about it in a second, okay? So let's keep the cloud for this real hot stuff, and let's do all the, let's say, average Joe stuff on-premise, very close to the device, okay? And the last but not least scenario for using the edge is the offline scenario, And this is somehow connected with what I said with the computing. An example, the Caucasus. Okay, so basically, uh, imagine the situation that you have a ship, and you start to collect the data from the ship, and you start your cruise. Okay, and everything goes smooth. You have the real-time analytics on the cloud. All the device management is done from the cloud level. Okay, if something goes too high with the temperature, you can decrease the temperature by simply remotely invoking some method or send some event, and so on and so on. And now imagine that the weather goes bad and you have no connectivity, and you are 100% depend on the cloud. Not the best idea. It's not the best idea. Yeah, I will tell a little bit better scenario when I will talk about the autonomous cars. Okay, but keep that in mind, that this offline scenario is very often, because when we lose the connectivity, we still should or even have to have the basic capability of our system. The core functionality should be there, okay, just in case to keep everything operational, okay, our ecosystem operational. If we have a production line and if we are dependent on the internet connectivity, forget about it, okay, forget about the revenue, okay, because there will be a moment that the cloud will be unavailable, the internet won't be there. Of course, it will be a few seconds, few minutes, but if this minute will be bad, you can lose your devices, okay. So let's keep it for the edge, so the offline scenario. Okay, but actually, I'm keep saying stuff about the processing, but what actually do we want to process? Okay, so first, we for sure want to process telemetry. What is the telemetry? The telemetry are the data points produced by the devices, okay, the information from the devices. A self-respecting telemetry data point has few information included, okay? So it has the information about the data producer, which particular device produced this data point, which particular signal this point is associated. Because if we have device like engine, we can have a few possible signals or the data sources on this engine. We can have a surface temperature, the inside temperature, we can have a torque, or even a power, a current power, yeah, of this engine. So it is wise to include that information into the telemetry, okay? So data producer, signal, the value for the signal, it is quite important if if this is 35 or 135 degrees, okay? This is quite a difference. And of course, the timestamp, when this data point was acquisited, because we are mostly interesting, and so far we were mostly interesting in the time series, basically. So with the data organized by time, because when the data are organized by time, we can start for looking for some trends, okay? If the temperature rises, we can find this trend. Okay, the temperature keeps rise, and it's rise 1 degree every 2 hours. So if it goes this way, after 10 hours, we'll have overheated device. Quite important, and we can get this information from telemetry. Okay. Then, of course, we can process a different type of messages from the devices, alarms or the events, depending on the client's definitions, depending on the system. I can give you the basic definition. The basic definition is the event is the information that something happened. Something happened, okay? The device was connected, the devices was disconnected, the devices restarted itself, and so on. While alarm is kind of the event that needs to be taken care of. Okay, so someone needs to take care of this event, and this situation makes this event an alarm. Okay, so someone has to acknowledge that, okay, I taking care of that situation, because the event can be also the information that device is overheated. Okay, but I would rather consider this kind of event as an alarm. Okay, if this is overheated, good to know, but what to do with that? Okay, so yeah, we can also process them, the situations and the information like this. And the last, again, but not least, my favorite, the context. We should also to process context, and trust me, we want to process context, not only on the cloud, but also on-prem. Okay, so what is the context? Back into the telemetry. Okay, the context of the telemetry is, in example, the surface temperature. The surface temperature can be somehow depend on the weather. Okay, if we have a huge surface of our device, okay, and this surface start to heat itself, so we can assume that it will be it will be warmer a little bit faster on the really sunny day where we have 40 Celsius degrees, while it will be a little bit colder on the days when we have like -5 Celsius degrees. Okay, so this gives us a context, because only processing the signal, we have the operational information. What is the current state? What was the state before? And we can predict, okay? If we have the data ordered by time, we can start to predict, okay? But add the context, okay? The context can be the weather, like in the scenario, okay? Because if the surface temperature normally is like, I don't know, 40 degrees, when we have -5, okay, outside, it can be cooled continuously, and this 32 degrees is still okay. It's not too low, it's still okay. Okay, so it worth to remember, Another thing, I believe it's also at least as important as the what I said previous, the context of other signals. Okay, because we can notice the situation when one signal value rise, okay, and the second signal value is decreased, okay, and they are still in the operational boundaries. They are still okay if we consider them as a units, okay, as a single signal. It's still okay. It's still between somewhere between minimum and maximum allowed values, okay. But for the, in example, experienced engineer, the situation when one signal goes up and the second signal goes down is the error, is a fatal error, because they are strongly, they should be in line. If one goes, the second goes as well. Okay, if one is decreasing, the second should be decreased as well. Okay, and if we have this situation, one goes up, one goes down, this is the error. And this is the context. This is we adding the context of the second signal to the first signal, okay, and then the opposite way, of course. Yeah, so this is very important. We want to process the context as well. Okay. So what options of the data processing do we have? Okay, I can only say that I will say that this on-premise and the cloud, and let's try to figure it out. What I can say, we have a lot of these options. And I have to say right now to you that this split between on-premise and the cloud possibilities is not so straight, it's not so crisp anymore, okay? Because imagine the situation, in example, prediction software. This is the example. I never use it. I just read about it. It's processed some data. This is the data processor, okay? And you install it on your PC, okay? And you just connect some signals and it starts to process. I see no problem on creating the virtual machine in the cloud and simply install it on the virtual machine and do this connection of redirection of the signal and do the same processing. No problem. And then you have the same solution working on premise and on the cloud. Of course, the cloud providers want to give you the managed version of a lot of services, even the data processors. It means basically that you have very similar or the same or the very similar functionality of some solution, but a lot of is managed for you. So you really don't have to worry about, in example, the software updates. You don't really want to, you really don't have to focus on the operational system updates, security patches, installation, and so on and so on. They will do it for you, of course, for some cash. for some gold, you can say, yeah. Okay, but you still have very popular microservices. You can create your cluster on-premise as well as on the cloud. You can write your native solutions in a language you like. I don't know, standalone application in Java, in C#, and so on. The same you can do on the cloud. You can use, I don't know, the Azure functions on the Lambdas to create the code solutions that will be just run for you in the cloud, but still can do exactly the same stuff with your data. Okay, we can have few hybrids, like an example, Hadoop, or stream analytics that can be run on the cloud as well as on the edge framework. You can even have cognitive services, okay, from Azure that are available on the cloud. Yeah, you just deploy them and you have REST endpoint, and you can just send the data to this REST endpoint and retrieve the answer, yeah, or the results of the analytics. I don't know, for the speech recognition, person recognition, I don't know, you can imagine. You can imagine that I will show you the possibilities if you still have time, okay? But still, there is a possibility that you simply go in the configuration of this cognitive service of Azure in the Azure portal, and you just created a container out of it. And since you have the image, the Docker image of it, you can simply create a container out of it, whatever you want. In example, on-premise, yes? So this split between on-premise and the cloud is not so crisp, is rather fuzzy. I know what I'm saying, okay? But let's try let's at least try to compare what is possible on the cloud, what is possible on the on-premise, okay? So how to process data? We have 4 basic possibilities. The first one is using inbuilt capacity of services in your ecosystem. What I mean by that? On the edge, in example, we can have, and by edge this time I'm talking about the IoT Hub Edge framework. Okay, strict. What is possible there? Okay, because let's try to focus on that, because I'm the Azure guy and we are on the cloud computing path. And on the cloud, I mean, of course, Azure cloud. So on the edge, in example, you can have the stream analytics and the microservices. Okay, and since you can simply download the image from, I don't know, Docker Hub of some data processor, you can say that you are using inbuilt possibilities of this component, this module, of course. Yeah, so you can run it as a module on the IoT edge and simply use the analytics which it provides, in example, yeah, or using the processing capabilities that it offers. The same with the stream analytics. The stream analytics allows you to be deployed on the edge, yeah, as a module, and then you simply configure it from the cloud and then deploy it, yeah. So push this basically to the edge using the edge framework and IoT Hub. But actually, this is you can use the inbuilt capacity or possibilities of this service. So you calculate the aggregates, or even now use inbuilt machine learning algorithms like, I don't know, anomaly detection. Why not? You can still use it on premise. On cloud, it's simple as on the edge, basically, because you can still use the stream analytic, logic apps. Logic apps I only gave to have one more on the cloud than on the edge, but it's not really necessarily a huge advantage, okay? Microservices on the cloud, of course. I don't know, Hive if you have some Hadoop cluster and so on and so on. But actually, I recently read about this Hive in containers. So if there is a Hive on the container, if your Imagine allows you to do that, you can have your you can have your data lake on premise as well, and simply use the Hive on your edge. I see no problem with that, depending on your hardware and pretty much Imagine. Okay, let's moving a little bit forward. Using custom code on premise, stream analytics, microservices. On cloud, stream analytics, microservices, and pretty much Azure functions, but it's not a huge advantage, since whatever you put in Azure function, it can be pretty much done from the data processing perspective on the microservice. okay? Using advanced AI-based solutions from portfolio, why not? So you can use, again, the stream analytics, cognitive services, and the microservices, yeah, with the AI-based solution from Docker Hub, why not? And in the cloud, surprise, you can do actually the same stuff, okay? Using custom AI-based solutions, like an example, on-premise, stream analytics, code in Python, you can develop your own solution. The same, pretty much, you can do on the cloud. And what I'm trying to say here, I'm trying to say that Edge is not longer poor cousin of the cloud. It's fully functional framework that allows you to develop your solutions against the data which are very close to you. You don't have to put everything on the cloud anymore. You can do some analytics, some processing on premise close to the device. When this processing and pretty much results of this data processing and analytics is needed, and it's needed immediately, okay? Okay, now let's smoothly go to this earn money part. I would make it really fast because I'm seeing we are running out of time, but earn money. First scenario. The first scenario is autonomous cars, okay? Most probably you heard about autonomous cars. You heard about all these sensors which is installed on the roof of such car. You also most probably heard about some accidents with the autonomous cars. For sure, you heard about the 5G. And I know really from the good resource that 5G is really done mostly on demand of the automotive. Okay, why I say I know that? Because one Swedish telecommunication company has most patents. I don't know if this is the right translation. Patents from the field of the 5G, and I know from the guy who works in this company that they started because of the automotive. Okay, but this is the part of the research I read. Currently, you can say that the autonomous car, as well as the cars which will be sold in the future when this 5G will become a little bit more popular, you will be able to name it as real edges on wheels. Why? Because there will be a lot of calculations done basically live, okay? Why live? I had a really nice explanation of that. Imagine a car running on the highway, 70 miles per hour, and the lack in the connectivity. Yeah, so you can imagine what will happen. Of course, I know that we can have a really nice analytics done on the cloud. I really a huge fan of the Hive theory, okay? And this Hive theory, in my opinion, should be the way where this autonomous car management, let's say, road management should go, okay? Because there is a sense of using autonomous cars and try them to be real independent if they will be able to communicate with other participants of the road. Okay, so if they will be able to decide that, okay, I won't hit this car, but I need to go right or left, but I will hit this guy, so I can ask this guy that I'm going to hit eventually to reduce the speed a little bit. So then the crash won't happen, or the results of this accident will be minimal. Okay, so the Hive theory can be the answer for that. And this shows why the edge is so important there, because you can do the live analytics basically where the data are, okay? Because there is no sense if sending the information that I'm 15 centimeters from another car and this car is stopped and I'm driving 100 kilometers per hour, because before I send this data to the cloud, I will already hit it, okay? That's why the edge is so important here, okay? The second thing, the bonus use case, is the healthcare and the smart city. And basically we have two scenarios here. Of course, dealing with the patient's data is very, very problematic because of legal aspects of this problem. But before we start to say about anonymizing the data, the edge can improve the working of the hospitals, not only from the perspective of the patients, but perspective of the smart houses, okay? Because we can imagine the hospital as a data source where a lot of devices are connected, incubators, USGs, and so on, okay? We need to monitor them. We can use the cloud or we can use on-premise solution, yeah? But also the smart building, the current usage of energy, the current production of energy, and so on and so on. And we really encourage you to read a little bit about that, okay? The final, I wanted to say a little bit about the windmills, okay? To make long story short, we work with the clients who had the windmill farm on the middle of the ocean, and basically they struggling with the analytics, okay? The most important, they were missing a context, okay? Because they not really taken the weather predict under the consideration, but this is another thing. They hired the data scientists and they did the great job. They start to save a lot of money. But the problem was with the calculation live, okay, on how the windmills should behave on the tough conditions, okay? And by the tough conditions, I understand in example storm. When this transfer to the cloud, data to the cloud was simply impossible, but the actions needs to be done live, okay? If the wind started to blow, they in example wanted to start the electrical engine, okay, to start windmill to turn around, okay, that it will in example help the wind, okay, so it will allow us to save the bearings and so on. Yeah, so I wanted to say a few more words, but I'm sorry, but we are running out of time. So thank you for this, guys. I hope we can discuss a little bit in the rest of the time. Yeah, I hope there are some questions. So now, thanks again, and oddaję głos do studia.